Guys, a woman can swim 5/9 in still water. She swims across a river 250 meters wide. The river flows at a constant speed of 5-6 meters per second parallel to straight banks. This means the river is faster than the woman. Find the shortest time it will take to cross the river. No bother. The woman has to cross 250 meters and she's just going to aim all 5/9 directly upwards. Speed equals distance over time, and you just say no bother, 250 divided by 5/9, and that'll get you 450 seconds. Pretty easy question, right? That's that first one done. Now the next question is, we're going to call it the woman and the river, okay? And we're going to say that the velocity of the woman in the river, which is the woman in still water, is the velocity of the woman minus the velocity of the river. Now if you aren't sure about this type of question, rearrange the equation as velocity of the woman equals the velocity of the woman in the river plus the velocity of the river. Now if this doesn't make sense to you, I suggest you write a very simple example down for you. A woman can swim 2 meters per second in still water. Okay? In still water. A river flows 3 meters per second. An observer on the bank will actually see the woman go 5 meters per second. So the velocity of VWR is still water. Okay, the blue part is still water, the yellow part is the river, and that's the way it works. Next thing we're going to do is the woman wants to cross the river. Okay, and we set up this equation, and it usually has 6 items of information. Okay, so 6 items of information to make this work. And what we have is magnitude and direction. Okay, now we know the velocity of the woman in still water is 5/9. We know the velocity of the river is 5-6, and we know that the river goes east. When I do this question, we're setting up that the woman has to aim downstream, and then she's going to get swept upstream. Okay, and we're using the triangle law, that the velocity of the woman equals the 2 other vectors, the VWR and the VR added together. Okay, and what we have here is the velocity of the river and then the velocity of the woman. So she aims downstream, she gets swept upstream, and this is the direction she actually goes in. Okay, now we put in our numbers. Now when I do this question, and you see the way you have 3 items of information, 3 items of information out of the 6, this means you're going to set an angle to 90 degrees. Okay, now I'm going to put information opposite each one. So x equals 5/6, x is going to be opposite 5/6, and angle y is going to be opposite 5/9. I'm going to set up a sine rule. Okay, so here's my sine rule here. Okay, now in this sine rule you're going to set one of these angles to 90 degrees. Okay, and only one of them is possible. So when you obviously bring the 6 and the 9 down underneath, you can cross off the 5's, okay? And what you then get is 9 sine y equals 6 sine x. If you isolate sine y, you get 6/9 sine x. Okay? Now you got to remember, if you did it the opposite way around, you would have got sine x equals 9/6 sine y. And if you put sine y equal to 90 degrees, you'd get sine x equals 9/6, and that number's too big. You can't do that way. Okay, sine inverse 9/6 doesn't exist. So we put x equals 90 degrees, we get sine y equals 6/9, which is 2/3. Now the other thing to remember is you want the woman to go as vertical as possible, and the angle y is alternate. So the larger the angle y, the straighter you go. Okay, so that's why we want y to be as large as possible, and that's why we need x to be 90 degrees to make it as large as possible. Okay, so what we're going to do next, lads, is we know that this is now a right angle triangle, and therefore it obeys Pythagoras' theorem. Okay, so this obeys Pythagoras' theorem. So that's 90 degrees, and here's what we can do. I can find out the speed that she goes off in. So this little line here, I'm going to find out what speed she's actually going. Okay. Now, the longest side is 5/6, so it's 5/6 squared equals 5/9 squared plus VW squared. Okay, and then we'll just do 5/6 squared 5/6 squared, and then it's going to be take away 5/9 squared, and what we get here is this number here, 125/324, we square root it, and we get 5√5/18. Now, the great thing about this angle y is we now know we're going in this direction, and we can also calculate the entire distance we travelled in that direction, because we know that you have to go 250 upwards. Okay, so what we can do here is we can say that 250, and this is angle y, and sine y is 2/3, and we can find out the entire distance d that the woman that the woman covered as she got swept downstream, and it's in the same direction as her VW. Okay, so what we can say here is that it's sine y is 250/d, so d equals 250/sine y, and sine y is 2/3. So 250 divided by 2/3. Now it's pretty late at night, so I'm not trusting myself with doing anything smart. 375. So she travels 375 meters downstream. Now time equals distance divided by speed, which is 375 divided by 5√5/18. I believe we're looking for minimum time. Find the time taken. Okay, so here's hoping this works. 375 divided by 5√5 divided by, divided by 18. Oh, it didn't come out as a third. That is very frustrating. Okay, let me see what I can do with that. 375 divided by 5√5. Yes, 15√5. Okay, so it's 15√5 divided by 1/18. Then 18 multiplied by 15. Sorry, answer multiplied by 18. Oh, I did it again. So what's 15 multiplied by 18? 270. So it's 270√5. Well, that was a frustrating question. Okay, that was pretty handy.